Students, so today we are going to study methods of concentration of ore. In the previous lecture we have studied physical method for the concentration of ores. Now in this lecture will study methods of concentration of ore but by chemical method. Now which are the two chemical methods? One is Bayer's process and one is Hall's process. Now what is Bayer's process? We'll study in detail. Firstly, aluminium is the third most abundant element in the Earth's crust after oxygen and silicon. Aluminium, its atomic number, its symbol is Al. Atomic number is 13. Electronic configuration 2,8, 3. So its position will be in periodic table. Its position is outermost orbit contains 3 electrons, so it is group 3. It is a normal element, so A. So it is placed in which group? Group 3A. And what is the period number? Since it has 3 orbits, so period number is 3. Then for the process of extraction of aluminium, basically the main ores of aluminium. What are the ores of aluminium? Ores of aluminium are bauxite, cryolite and feldspar. What is bauxite? Al2O3 2H2O. Cryolite is Na3Alf6 and feldspar is potassium aluminium silicate. Sorry, calci 3 oxygen 8. So these are the ores of aluminium. But the main ore of aluminium is bauxite. Okay, so bauxite is the main ore of aluminium. Now what are the process involved? Firstly, there are 3 steps. What are the 3 steps in metallurgy? First is preliminary treatment. What is preliminary treatment? Preliminary treatment is nothing but dressing of ores, or we can call it as concentration of ore. Second one is reduction and third one is refining. So preliminary treatment, reduction and refining. So for the extraction of aluminium, what is the preliminary treatment? I mean, what is the method for the concentration of ore? For concentration of ore of aluminium, we are using a process called as Bayer's process or Hall's process. We'll study in detail about these two processes. So we'll start with Bayer's process. What is Bayer's process? So in the method of concentration of ore, what is the main requirement? We need to remove the impurities. Now bauxite is nothing but Al2O3 2H2O. It contains impurities. What are the impurities it contains? So bauxite contains impurities. Impurities are iron oxide and silica, so bauxite contains impurities like iron oxide and silica. So in the method of concentration of ore, we need to remove the impurities. For concentrating the ore, we need to remove the impurities, and these impurities are called as gangue, Gangue. So here we'll concentrate the ore by a chemical method that is called as Bayer's process. So bauxite contains impurities like iron oxide and silica. Firstly, ore is powdered and crushed. Ore is powdered and crushed and washed Then it is heated with, ore is powdered and crushed and heated with aqueous sodium hydroxide. Aqueous sodium hydroxide is called as caustic soda. Now what will happen over here? Now when it is heated with aqueous sodium hydroxide, it is heated under high pressure for 2 to 8 hours at 140 to 150 degrees Celsius in a large steel tank. Now what will happen after heating? We'll repeat again. Bauxite is the main ore of aluminium. Bauxite contains impurities like iron oxide and silica. The entire ore is powdered and crushed and heated with aqueous sodium hydroxide. Now entire ore contains what? Al2O3, iron oxide and silica. We need to remove these impurities and finally we have to get only Al2O3, and that will be concentrated Al2O3 after the removal of impurities. So entire ore is powdered and crushed and heated with aqueous sodium hydroxide. Now what will happen? Now aluminium oxide Al2O3, will it react with aqueous sodium hydroxide? Firstly, aluminium oxide is an oxide of metal. We have studied the properties of oxides of metals. What are the properties of oxides of metals? Oxides of metals react with acid, and what they form? Salt and water. Now salt and water is formed in a neutralization reaction. What is a neutralization reaction? Acids and base in their aqueous solution react with each other to produce salt and water. But here something is reacting with acid and it is forming salt and water. But by default what we can say? Acid reacts with base to form salt and water. Here acid is reacting with someone else to form salt and water. That means this should be what? Base. Why? Because we know that acid reacts with base to form salt and water. Here oxide of metals react with acid to form salt and water. That means oxides of metals are nothing but they are acting as base. That's why we call oxide of metals are basic in nature. So generally oxides of metals react with acid to form salt and water. They will not react with base. But there are some oxides of metal like aluminium oxide. Since it is an oxide of metal, it will definitely react with acid and it will form salt and water. But at the same time, aluminium oxide Al2O3, it also reacts with base and it forms salt and water. But what we have studied, generally oxides of metals will only react with acid to form salt and water. Aluminium oxide being oxide of metal, it will definitely react with acid to form salt and water. But at the same time, aluminium oxide also reacts with base to form salt and water. Here we can say that aluminium oxide, when it reacts with acid, it forms salt and water. So while reacting with an acid, it behaves like a base. At the same time, aluminium oxide also reacts with base to form salt and water. We can say here it is acting as acid. While reacting with an acid, it behaves like a base, and while reacting with a base, it behaves like an acid. Such oxides of metals are called amphoteric oxide. What they are called? Amphoteric. So what is amphoteric oxide? Oxides of metals which react with acid as well as base to form salt and water are called amphoteric oxide. Aluminium oxide is an example of amphoteric oxide. At the same time, zinc oxide is also an example of amphoteric oxide. So what is amphoteric oxide? Amphoteric oxides are oxides of metals which react with acid as well as base to form salt and water. While reacting with an acid, it behaves like a base, and while reacting with a base, it behaves like an acid. Now what we have done, how we will concentrate this one. This is what a Bayer's process. So So bauxite contains impurities like iron oxide and silica. We need to remove these impurities. So what we did, we have heated with, firstly we powdered the ore, then it is heated with aqueous sodium hydroxide under high pressure for 2 to 8 hours at 140 to 150 degrees Celsius. Now aluminium oxide, will it react with base? Definitely it will react with base. Why? Because aluminium oxide is amphoteric oxide. So it will react with base. It will get dissolved in aqueous sodium hydroxide. That means aluminium oxide is leached by aqueous sodium hydroxide, that is caustic soda. Large steel tank consists of aqueous sodium hydroxide. We have three things: aluminium oxide, iron oxide and silica. Now what happens? Aluminium oxide, it get dissolved in aqueous sodium hydroxide. Silica also dissolves. Aluminium oxide get dissolved in aqueous sodium hydroxide. What will be the reaction? I'll explain. Al2O3 reacts with base to form salt. Here the salt will be NaLO2, that is called as sodium silicate, sodium aluminate, salt and water. The aluminium oxide dissolves in aqueous sodium hydroxide to form which salt? Sodium aluminate. That means aluminium oxide is dissolved. What it has formed? Sodium aluminate. Silica also dissolves in aqueous sodium hydroxide to form water soluble sodium silicate. Silica also dissolves to form so we can say aluminium oxide is amphoteric oxide. So it dissolves where? In aqueous sodium hydroxide to form water soluble sodium silicate. Silica also dissolves where? In aqueous sodium hydroxide. What it forms? To form water soluble sodium silicate. But this iron oxide, it is the oxide of metal. It is not an amphoteric oxide. It will only react with acid. It is not going to react with aqueous sodium hydroxide. So it will remain unaffected. Iron oxide will remain unaffected. Iron oxide remains unaffected. Now if it remains unaffected, we can say it can be removed by filtration. Now, three things: aluminum oxide, iron oxide, silica. They are heated with aqueous sodium hydroxide in a large steel tank under high pressure for 2 to 8 hours and at 140 to 150 degrees Celsius. What happens? Aluminum oxide, since it is amphoteric, so it gets dissolved in aqueous sodium hydroxide to form water soluble sodium aluminate. Silica also dissolves where? In aqueous sodium hydroxide to form water soluble sodium silicate. But iron oxide remains unaffected. Why? Because iron oxide is an oxide of metal. It will react, generally what I said, oxide of metal will react with acid. It was an exceptional case for aluminum oxide. Why it got reacted with base? Because it is amphoteric oxide. But iron oxide remains unaffected, so it can be removed by filtration. See, after filtration, since it was not affected, others got leached. Leached means they got dissolved. They got dissolved in aqueous sodium hydroxide. So iron oxide remains unaffected, so it can be removed by filtration. See, after filtration, we can filter out iron oxide. Since it is unaffected, we can filter it out. So after filtration, the liquid obtained is called as filtrate. What is filtrate? Filtrate is nothing but the liquid obtained after filtration is called filtrate. So iron oxide remains unaffected, so it can be removed by filtration. What is filtrate? The liquid obtained after filtration is called filtrate. So here we can remove iron oxide by filtration. The liquid obtained after filtration is called filtrate. Now it will contain sodium silicate and sodium aluminate. So what we know, filtrate, it will contain sodium aluminate and sodium silicate. See, what is the process? Process is what? Concentration of ore. We need to remove the impurities. We need to finally get Al2O3. Till now we have removed the impurity iron oxide. We need to get finally Al2O3. Now our filtrate contains sodium aluminate. We have removed iron oxide. So what will remain? Sodium aluminate and sodium silicate. So from which we can, out of these two things, sodium aluminate and sodium silicate, we can get aluminum oxide from where? Aluminum compound, I can say sodium aluminate. See, in your Maharashtra board syllabus, they have skipped some of the process. There is a process called as seeding and all. It has been skipped. So directly it is given. Now we need to get aluminum hydroxide first. See, sodium aluminate, that is NaLO2, is diluted by putting in water. It will result into precipitation of aluminum hydroxide. We can say sodium aluminate is diluted by putting in water. Sodium aluminate is diluted by putting in water, and then it is cooled to 50 degrees Celsius. Why it is cooled to 50 degrees Celsius? Because temperature is how much? 140 to 150 degrees Celsius. So after diluting NaLO2, that is sodium aluminate, by putting in water, it is cooled to 50 degrees Celsius. This results in precipitation of aluminum hydroxide. It forms both hydroxides, aluminum hydroxide as well as sodium hydroxide. But cooling to 50 degrees Celsius results in precipitation of aluminum hydroxide. This is the precipitate. Actual process is what? We need to add little aluminum hydroxide to the filtrate, and we need to stir the filtrate, and then we have to put water and then cool to 50 degrees Celsius, which will result into precipitation of aluminum hydroxide. But in your textbook it is said that diluting sodium aluminate by putting in water and then cooling to 50 degrees Celsius results in precipitation of aluminum hydroxide. In actual, what it is, we need to add little aluminum hydroxide to the filtrate and stir the filtrate. which will result in precipitation of aluminum hydroxide. This is called as seeding. Anyway, so we got the filtrate, we got the precipitate aluminum hydroxide. Now this precipitate aluminum hydroxide, AlOH thrice, can be filtered out, can be removed, filtered. After filtering, we can wash it. After washing, it can be dried, and then it is ignited at 1000 degrees Celsius to get, we can get Al2O3 and H2O. Finally, we got concentrated Al2O3. This is called as alumina, and this process is called as Bayer's process. So what is Bayer's process? Firstly, bauxite is the main ore of aluminium. Bauxite contains impurities like iron oxide and silica. Ore is powdered and crushed and heated with aqueous sodium hydroxide under high pressure for 2 to 8 hours at 140 to 150 degrees Celsius. Out of this ore, aluminium oxide is amphoteric, so it dissolves in aqueous sodium hydroxide to form water soluble sodium aluminate. Silica also dissolves. What it forms? Sodium silicate. But iron oxide remains unaffected, so it can be removed by filtration. Then, now filtrate contains sodium aluminate and sodium silicate. What we need to do? Diluting sodium aluminate by putting in water, and then cooling to 50 degrees Celsius. It will result in precipitation of aluminum hydroxide, and this precipitate is filtered, washed, after washing dried, and then ignited at 1000 degrees Celsius to get Al2O3, that is called as alumina. So this process is called as Bayer's process, and in this process we have removed the impurities. Okay, so So what is Bayer's process? First point we can say, bauxite, there is Al2O3, 2H2O is the main ore of aluminium. Second point, it contains impurities like iron oxide and silica. Then we can say ore is powdered and crushed. Ore is powdered and crushed and heated with aqueous sodium hydroxide, that is also called as caustic soda. Under high pressure for 2 to 8 hours in a large steel tank at 140 to 150 degree Celsius. Now what happens over here? What it contains? Bauxite contains Al2O3, iron oxide and silica. It is heated with what? Aqueous sodium hydroxide. What will happen? Aluminum oxide, since it is amphoteric, so it dissolves in aqueous sodium hydroxide to form water soluble sodium aluminate. So we can say aluminum oxide, that is Al2O3, is amphoteric. So amphoteric oxide, so it dissolves where? In aqueous sodium hydroxide. So it dissolves, or we can say, or leached in aqueous sodium hydroxide to form water soluble sodium aluminate. Then we can say silica also dissolves where? In aqueous sodium hydroxide. What it forms? Water soluble sodium silicate. We can say silica also dissolves where? In aqueous sodium hydroxide to form water soluble sodium silicate. Now after writing the fourth point, you can write down the equation. Equation is Al2O3, that is bauxite, aluminum oxide. It contains water molecule, 2 molecules of water. It gets dissolved in aqueous sodium hydroxide. What it forms? Water soluble sodium aluminate, that is NaOH and water. This is called as sodium aluminate. You can balance it out. Then silica also dissolves in aqueous sodium hydroxide to form water soluble sodium silicate. But what happens? Iron oxide remains unaffected. Now if it remains unaffected, it can be removed by filtration. We can say iron oxide remains unaffected, so it can be removed by filtration. The next point. Now what should be the next point? This is aqueous solution of sodium hydroxide. In this, iron oxide got unaffected, whereas aluminum oxide, it got dissolved to form sodium aluminate, and silica also got dissolved to form sodium silicate. So iron oxide got removed by filtration. The liquid obtained after filtration is called as filtrate. Filtrate contains sodium aluminate and sodium silicate. We are interested in sodium aluminate. So what will happen? What we will do? Direct process. You can write down the answer over here. So diluting sodium aluminate by putting in water, we can say aqueous sodium aluminate. Aqueous sodium aluminate is diluted by putting in water, and then it is cooled to 50 degrees Celsius. This results in the precipitation of aluminum hydroxide. Then you can write down the equation for this. The equation is NaOH2, that is sodium aluminate, diluted by putting in water. Now when it is added with water, we can say it results in the formation of sodium hydroxide and aluminum hydroxide. It will form AlOH thrice plus sodium hydroxide. Now this is formed as precipitate. You can balance the equation. Balance equation will be aluminum, we can say directly, you can write down sodium 1 hydrogen 3 4 it is balanced. So NaOH2 is diluted by putting in water. It forms aluminum hydroxide as a precipitate. What will be the next point? The precipitate is filtered out. The precipitate is filtered out, or we can say filtered. After filtering, it is washed, then dried and ignited or calcined and ignited at 1000 degrees Celsius. We can say AlOH thrice is filtered, washed and ignited at 1000 degrees Celsius. What it will form? Al2O3 and water. Thus we got Al2O3. This Al2O3 is nothing but aluminum 2, over here is 1, hydrogen 2 3 are 6. Yeah, this is called as alumina. Finally we got Al2O3 by a process, and this process is called as Bayer's process. So we have obtained alumina, that is Al2O3. Now it is free from impurities. Now this process is called as Bayer's process. So finally we can write down this process is called Bayer's process. So you can note down these answers. These many points you need to write down for your answer. That's all. We have completed Bayer's process.